Welcome to Inside xtUML, the How-To series. My name is Dean MacArthur, and I'm joined by Cortland Sterrett. In this segment, we will show how execution of the analysis model can answer some early systems engineering questions. An easy-to-understand system consisting of two domains will be used to illustrate the ideas. In episodes 3 and 4 of the Inside xtUML learning series, the xtUML process for systems analysis and implementation was introduced. For this process, there are four key participants: the systems engineer, the component designer, the test engineer, and the integration engineer. Each of these participants has a key role in the production of high-quality xtUML models and ultimately high-quality implementations. For the system engineer, their role is to perform analysis on the requirements and to emerge from that work with a set of system components and interfaces. It is this collection of model elements that combine to create the concept model. Note that while performing analysis, systems engineers will allocate the functionality of the system to various system components. Although assigned to a component, each piece of functionality is not implemented until the component designers begin their design activities. It is mostly during these design activities that alternatives are explored and solution models created. The analysis model that we will work with in this segment covers the concept model and the early solutions models. It is characterized by components that are void of internal functionality and only limited interface behavior. For many of the requirements and system behaviors, there will be use case, sequence, and activity diagrams to support the functional analysis activities. However, there are also non-functional requirements that can influence the structural description of the system, and often dynamic or simulation-based analysis is the fastest means to finding the optimum answer to these questions. Waiting for a functional component model requires the project to proceed based on initial assumptions and accept the risk of delay if results show the assumptions are wrong. With xtUML, there's a better alternative, which involves adding a small amount of action language to the interfaces of each component. This action code will be triggered by message activity within the system model, and by executing the xtUML system model, assumptions can be replaced by precise answers. To demonstrate this approach in action, my colleague Cortland Sterrett will use a two-component system as shown here. Our demonstration will begin with an empty project, and then proceed through the steps to capture the analysis model, and then add action language. The final step will be to execute the model and accumulate the data that will supplement the functional analysis already performed.
xtUML model from scratch. So we start by creating a new xtUML project. We give it a name. We choose a model compiler for it. So I'm going to choose the binary C model compiler. Finish the project. It creates the new project, which I immediately open, and I create two packages. The first package is the components that I'm going to create. This is a library package, and then I will create a system deployment package as well. I enter into the components package, and I'm going to add two components. The first one I'm going to call amp for an amplifier, and then I'm also going to create a driver component. Next, we'll add an interface between the amp and the driver, and we'll call it interconnect. We'll add a couple of signals to this. The first one we'll call stimulus, and the second one we will call response. For response, we will change the direction. Instead of being to provider, it will be from provider. Next, we add the interface references to these components and formalize them to the interface that we've created. One side is the provided, the other side is the required interface. The required interface has a cup shape on the end of it. The provided interface has a ball shape on the end of it. We have the stimulus and response messages, but these messages do not have any parameters yet. So let's add parameters, size, weight, and power. We'll make the weight and the power real, and we'll leave the size defaulted to the integer type that it defaults to. Let's return these same parameters on the response message, and so we'll copy and paste these parameters from one message to another and save some mouse clicks. So now we have an amplifier component and a driver component with an interface that describes the messages that go between. And so now let's enter our system package and connect our system up in a deployment arrangement. So we will go into the components, and instead of adding a component, we will add a component reference and assign that component reference first this one to the amplifier. We'll create another component reference and assign that to the driver component, and now connect these together. And now we have a deployment system with a connected set of components that talk to one another. Let's add one more message to our interface that will allow the system to be initialized, and so we'll call it init, and we'll make this a from provider message so that it is initializing. The initialization begins with the amplifier component.
With the analysis model now containing the structure of the proposed concept model, the next step is to add action language to the interface messages.
We will now add behavior to this initialization message to send the stimulus message from the amplifier component to the driver. So we'll send a message out port 1, stimulus, and we'll send a size value of 4 with a weight value of 3.1 and a power value of 1.0. In the driver component, when we receive that stimulus message, we will send a response and we will take our size that we received and we'll add 5 units to that. Let's say this is grams, or a volume of cubic millimeters. So then our weight in grams will be the incoming weight with 3.7 grams added to it. And our power is our incoming power multiplied by 0.84 to reduce our power budget by 84% because we have a 16% drop in this component. We have now added minimal behavior to our deployment system, and so now let's run a simulation. And so we'll open the xtUML debugging perspective. We'll go to our debug configurations, create a new model verifier configuration. We'll call it swap, and we'll select the deployment system package as what we want to run. We will log our execution activity and we will set our init message as the initializer message and start up the debug simulation. It will invoke the initialization message and begin the simulation.
This concludes our discussion on how to add execution to your analysis models. Please continue to regularly check the xtUML channel on YouTube for more segments in the Inside xtUML How-To series.